Good afternoon, geometry students. I hope you're having a fantastic day. I am going to be teaching you a little bit about circles today. Chapter 11 has a lot to do with volume and surface area. And the more difficult problems in the chapter have to do with 3D images, some of which we are going to construct out of circles, for instance, a cone or a cylinder. So in order to be able to understand those three-dimensional figures, it's going to be important for you to understand information about two-dimensional circles. So we have a few vocabulary words and a few examples to do today. The first vocabulary word is circumference. So you can write down circumference. And we do have a formula for circumference. Circumference is 2 pi r, where r is the length of the radius of a circle. Now, since the diameter is the same as 2 pi, we have a backup formula for circumference, which is just pi d. So either one of these formulas work. They are equivalent because 2 times r is the same thing as d. So let's do a few examples using that information. Example number 1, let's go ahead and find the radius of a circle with circumference equal to 36 pi. So they want to know, what is the radius of a circle if the circumference is 36 pi? Well, I know that circumference is 2 pi r. So 2 pi r has to be the same thing as 36 pi. Now, the nice thing is I can divide both sides of an equation if I want by pi. So I can do that here, and that will make the pi's cancel out. So now I have 2r equals 36. Then I can divide both sides by 2, and I can get that the radius is 18. So that's how we would do our problem if we wanted to find the radius of a circle with circumference of 36 pi. Let's do another example. Example number 2. Let's find the circumference of a circle with a radius of 22. So we're still going to use circumference equals 2 pi r. But now where it says radius, we're going to plug in 22. In this case, we would just take 2 times 22 and get 44. And we still have the pi there. So our circumference would just be 44 pi. Okay, let's do another example with circumference. Example number 3. Find the exact diameter of a circle with circumference equal to 24. So let's write down our circumference formula. I know circumference is pi d, and I also know the circumference is 24. So I can say that 24 equals pi d. And if I want to find the diameter, I would divide both sides by pi. This would cancel out, and I would have the diameter is 24 divided by pi. Now, if they ask for the exact diameter, I would just leave it that way instead of rounding. Okay, one more problem that has to do with circumference, and then we'll talk about some new information. So the fourth example here, we want to find the circumference of a circle that is inscribed in a square. So to inscribe a circle basically means that the circle touches the square once on each of the sides. And this question says, find the circumference of a circle inscribed in a square with a side length of 12. So we're assuming that the square has side length of 12. So notice if the side of the square is 12, that also tells me that the diameter is 12. So since circumference is pi d, I would know that my circumference would be pi times 12, or just 12 pi. So those are a few different ways that we might end up using the formula for circumference to solve various math problems. Now, let's go ahead and look at arcs of a circle. So the circumference of a circle is all the way around the circle. An arc is going to be a piece of the circumference. So we have two facts that we need to learn about the arcs of circles, and we will go over both of those facts now. All right, so let's talk about the measure of an arc. Measure of an arc. So let's draw an arc, and then let's circle, I should say, and then the arc is going to be a piece of the circumference. And let's label this central angle as 60 degrees. So an arc is a portion of the circumference, a piece of the circumference, and the measure of an arc is equal to the measure of its central angle. So if we call this arc AB, we would say the measure of arc AB is 60 degrees. So the measure of the arc is going to be the same as the measure of its central angle. Now, there's a difference between the measure of the arc and the length of an arc. So the measure is quite simple. As I said, it's just the same as the central angle. However, the length of an arc is different. So there is a formula for length of an arc. The length of the arc is basically asking, if I took a pink string here and I set it down on the circle, how long would that string be? Would it be 2 inches, 3 inches, 2 feet, 3 feet, whatever it would be? So it's the distance between the two endpoints. In this case, it would be the distance between A and B going along the side of the circle. So the length of an arc, the formula for that is L equals X over 360 times 2 pi r. Now, does anybody see how it is that this makes sense? Like, why is this formula the way it is? Notice that this piece of the formula is circumference. Circumference is 2 pi r, and this fraction in front of it is basically asking me how much of the circle do I want to take? How much of the circumference of the circle do I want to take? So let's do a particular example using that formula. We've got a circle here and a diameter, and then I have the endpoints of an arc AB and a central angle of 42 degrees. The radius is 4. So let's talk about a few things here. Let's find the measure of arc AB. The measure is simply going to be 42 degrees, right? Because it's just the same as its central angle. The measure of arc ACB, because there's 3 letters there, and let me go ahead and put the C here for you. The measure of arc ACB is going to be everything but the arc we just measured. So the measure of arc ACB is going to be 360 minus 42, which is going to be 318 degrees. So those would be 2 measures of arcs associated with that circle. However, if I want the arc length, let's find the arc length of BC. So arc length of BC. Okay, so I'm going to take the central angle that would be associated with that, which would be 180 minus 42, which is going to be 138 degrees. So from here to here is 138 degrees. And if I'm looking at arc BC, I mean this piece right here, the blue string. So I want to take 138, which is my central angle, and let's label that, by the way. This is my central angle. So I'm going to have 138 over 360 times 2 times pi times 4. Now I'm going to show you 2 ways to do this. One is the way that will be on your SAT exam, and another is a way that you can use usually in most homework or test questions. We can just turn this into a decimal if we want, but let's go ahead and talk about how we would do it if we want to have the exact answer. If we wanted to have the exact answer, we might divide both of these numbers by 3. using our calculators. So when we do that, we would have 46 over 120 times 8 pi. The 8 I got from taking 2 times 4. Now 8 goes into 120 15 times. So I'm going to divide this by 8 and I'm going to divide this by 8. Top and bottom are divided by 8. That cancels out. That just becomes a 1. And 120 divided by 8 becomes 15. So the exact answer to this would be 46 over 15 pi. Now, many students don't like simplifying fractions like that. So if you want, you can just take your original problem and multiply all the way across the top. So 138 times 2 times pi, be sure to use the pi button on your calculator, times 4, and then divide that all by 360. When you do, you're going to get about 9.63. So if you want to round to the 100th spot, that's what you would get. Okay, let's do one more example with arc length. So I think we had, 4 examples before this. This would have been example number 5 that we just did. Let's do example number 6 now, and this will be our last example. Let's draw our circle, and then we'll have the center be C, and then we have the radius of 6. In this particular problem, it's kind of interesting. They're telling us the arc length is 9.22, and they want us to find the measure of AB. So it's kind of working backwards. I'm going to use the same formula that I just did, but put things in differently. So I know that length of the arc is x over 360 times 2 pi r. My length in this case is 9.22. My central angle I don't know. And then that's times 2 times pi times 6. All right, so let's go ahead and take a look at this. I can bring down my 9.22. 2 times 6 is 12. 12 does go into 360 30 times. So I'm going to cross this out and put a 1. Cross that out and put a 30. So now I have 9.22 equals x over 30 pi. To get the exact answer here, I'm going to multiply both sides by 30 over pi. We're going to multiply by the reciprocal of what we have. When we do that, these 30s will cancel out and these pi's will cancel out. And I have here that x equals 30 times 9.22 over pi. And when I work that out, it's approximately 88 degrees. Okay, that's it. That was kind of a tough problem, but we can have a chance to go over more like it during class. And I will look forward to helping you. Thanks, you guys. Bye.